Okay, this is the homework help video for Honors Math 3, Unit 7, Assignment 3. So this is our log chapter. So for question number 6, we want to solve for x. So there's lots of different ways to get started on this problem. But the first thing I want to do is I see that I have a coefficient. So whenever I have a coefficient for a log, I can go ahead and move that up and make that a power on 9. So this 1/2 I will pull up and make that 9 to the 1/2 power. I'm going to do that the same for over here as well. So I'm going to move that 9 up, move that 1/2 power up, and I'm going to have, so I still have the natural log of x, so I haven't changed that. And then this will become natural log to the 9 of 1/2, right? So that's one of our log properties. Coefficients can become powers or vice versa. And so then this will become natural log of x minus 2 to the 1/2 power. Okay, so then from here, so I know that I have two logarithms. So whenever I have two logarithms on the same side of the equation, I always want to combine them, right? So if I have more than one, I always want to combine these. So I'm going to go ahead and combine these into one. And so I look to see that I have a subtraction. So whenever I have a subtraction, I'm going to use a log property that says that I can divide. So x will become the numerator, and then 9 to the 1/2 power is the same as the square root of 9. And so then this will become a square root as well, and then I would have that. So then once I have that, I know that the natural log of x over root 9 has to be equal to the natural log of root x minus 2. Since these are both natural log, then what I'm solving for is this part right here. I want these two to be equal to each other. So then that would be x over the square root of 9, which is just 3. And then that's equal to the square root of x minus 2. And then from here, I just want to solve algebraically. So I want to get rid of the square root. So to get rid of the square root, I'm going to square both sides. And so then when I square the left side, I want to make sure I square the numerator and the denominator. So that would give me x squared over 3 squared. And then over here, the root and the square root would cancel, leaving just x minus 2. And then to solve for x, I'm going to go ahead and clear my fraction. So I'm going to multiply both sides by 9. And so the 9s will reduce here, and then on this side, I'm going to distribute the 9 to both the x and the minus 2. So then now I get to a quadratic, and then once I get to that quadratic form, then I can go ahead and solve that like normal. So I'm not going to go ahead and do this part for you, but you would want to equal this to 0. So you'll subtract the 9x and the 18, so you want to equal this to 0. And then once you want to do that, or once you do that, you want to factor it to be able to use a zero product property. Okay, so equal it to 0, factor, and use the zero product property. Okay, let's go ahead and take a look at question number 12. So again, if I have a coefficient, so I have this coefficient of 3 here, I want to go ahead and move that up and make that a power on 3. And so I don't have a coefficient here, so this is going to stay the same. So then this will become 3 to the power of 3 and then equal to 0. So then again, if I have more than one log, so I can go ahead and choose to combine these, like that would be an okay step to do. But instead I'm going to go ahead and add this over to the other side. So again, not because I have to. More than one way to solve each of these problems, which gets a little bit tricky when we have different ways to solve things. So you might not have thought to do this. Instead, you might have combined, which is fine, right? That'll still get you the same answer. But I'm going to go ahead and add that to the other side. And then I'm going to go ahead and simplify this. So 3 to the power of 3, or 3 to the third, is 27. So then now what I have is I have log base 5 on both sides, and then absolute value of x is equal to 27. So with these, in order for these to be equal, this component, our values, is what has to be equal. So now I know that the absolute value of x has to equal 27, So then that means x is either 27 or negative 27. So I know that with that negative 27, that's fine because I have that absolute value there. If this was not here, I wouldn't have that negative. Okay, and then let's take a look at question number 14. So lots of different ways to solve this. So I want to go ahead and put these two logs together. Okay, so I want these logs to come together. So I'm going to go ahead and subtract this one over to the other side. So this will cancel here. And then a square root of x is just x to the 1/2 power, and then equal to 1. So then I want to combine my logs, so because I'm subtracting, then that means I'm going to divide my values, so I'll have x over x to the 1/2, and then equals to 1. So this is just a power of 1 here, and whenever I'm dividing, I want to subtract my powers, so I'm going to take that 1 and subtract 1/2. So I want to subtract 1 minus 1/2, which is just 1/2. Okay, so again, whenever we divide, we subtract our powers. So now I want to isolate the x. So if I want to isolate the x, then there's an implied base here of 10, right? So there's an implied 10 here. So again, different ways to do this, but I'm going to make this a power on 10, and if I do that to the left, I have to do that to the right as well. So again, I just made this a power on base 10, and I'm going to do that to this side as well. So then once I do that, 10 base with log base 10 will cancel, leaving me x to the 1/2, and then that's just equal to 10 to the first, which is 10. And then now I can just solve this like normal, so I'm going to square both sides. So the powers will reduce down to 1. So I have x to the first, or x, is equal to 10 squared, which is 100. Okay, and then question number 23. So again, lots of different ways to kind of attack this problem. So I'm going to do this a little bit different. So I want to solve for x. So if I want to solve for x, I don't like it up in this power. So I'm going to take that x and move it to the front, right? And I can do that because that's one of the properties of logs. So then when I do that, I will have x and then times log base 2 of 8. And then I know what this value is as well, right? So what power on 2 is needed to get 1/4? So I know 2 squared will get me the 4, and then to make it under 1, that would be negative. So again, what power on 2 will give me 1/4, and that would be to the negative 2 power. Okay. And again, I'm trying to solve for x, so I'm going to go ahead and multiply both sides by negative 2. Again, different ways to solve this. This is just one way. And then 1/2 of negative 2 is negative 1. Okay, and then this part right here, so I want to know what power on 2 will give me 8. So what power on 2 will give me 8, and that would be a power of 3. So I know that this part right here is equal to 3. So I have x times 3, which is 3x, and then that equals negative 1. And then I'll let you do this last step on that one, because that one is pretty easy on that last step. So then just finish solving for x there. Okay, so for 24, so I'm just going to get you started on this one. So again, I want to combine my logs. So when I combine logs, I'm going to go ahead and do that by multiplying the values. So I'm going to take that x and I'm going to multiply it to the x squared. So x times x squared is x cubed. And then in order to solve for x, I need to get rid of the log 8. So I'm going to make this a power on base 8. And if I do that to the left, I have to do that to the right as well. So 8 to the power of log 8, and then 8 to the first. So this would cancel, leaving me with x cubed is equal to 8, and then I just need to finish it out and solve for x. And that's it.